something that we can do is work with data and fit a linear model to that data. This is called linear regression. And if you've taken statistics courses before, you may have seen this already. But what we'll do is kind of talk about how to do it without technology, and then in the next video I'll show you how to use Desmos to get some exact values. But in this video we'll just kind of do estimations. So, the U.S. Census tracks the percentage of persons 25 years or older who are college graduates. And we have the dates for several years, and then the percentages matching up with those years. So from this table we can see, okay, in 1990, 21.3% of people 25 and older were college graduates. And then we can see it's kind of overall increasing trend. In 2008, 29.4% of people 25 and older were college graduates. So what we want to do is graph this data. And when we graph it, we're going to draw something called a scatter plot. It's where we're going to treat these as coordinates. We'll have year be treated as X and percent of graduates treated as Y. And we're just going to graph them in a scatter. And what that means is that they'll have these individual points, but we're not going to connect the dots. So what we have here, I set up the x-axis here to represent the year. And then along the y-axis, what I'm going to do is skip ahead on the y-axis because my values are mostly between 20 and 30. So what I'm going to do is, instead of seeing everything like 0 to 20 when there isn't any information there, what I'm going to do is use this little symbol, it's a line break, to show we're skipping over some numbers there. We're going to start at 20, and then I'm going to use units of 1, so 21, 22. But this just shows that the scale, like where this would represent a distance of 1, we're using the line break to show we're skipping from 0 to 20 because there's nothing there. But then we'll use a scale of 1 for our axis. So 23, 24, 25, 26, 27, 28, 29, 30. So what we're going to do is plot these points. So like 1990 was 21.3. So I'm going to graph about there-ish. And then 21.4 in 1992, a little bit more. And then we're just going to go through and graph each of these points. 22.2, 23.6, just estimating where they're landing. Alright, so if you want to pause the video and just graph these on your paper, or I'm going to pause and get these points plotted down so you don't have to watch me draw every single one. Alright, so this right here is our scatter plot with all of that data filled in. Now, we don't want to connect these dots because it's not like there was this linear trend between 1990 and 1992. We don't know what the trend is, especially if we don't have 1991 on our table. Maybe 1991 was up here or down here. We don't know. So because we don't know what's happening between the points, we don't connect them. Instead, what we're going to do is we're going to look at the scatter plot, and we want to imagine a line that goes through this data and fits as close as possible to all of the data points at the same time. So you can imagine is, let's see, I have some lines going there, but let's say I drew something like this. Like that seems pretty linear there. But notice how I completely missed those values on the outside. That isn't really this line of best fit that we're looking for. We're trying to be as close as possible to everything at the same time. And actually what I just drew there, I liked. So I'm going to draw with you would want to use a ruler or some sort of straight edge to get accuracy. I have a line function on my tablet, and that looks pretty good to me about being close to all of the points. This isn't going to be exact, but eyeballing it, we're just trying to get as close as possible to everything at the same time. So what I just drew there is this line of best fit, where we're trying to get as close as possible to all of the data at the same time. Now with this, we have this line that's following our data, and we can make predictions with it. So like in 1999, or actually, sorry, let's go to 2005. So that'll match up with what we do in the next video. 2005. We didn't have that data value, so we don't have any observed value, but what I do have is a predicted value. This line is giving me these predictions for what was occurring. So what we could do is predict what was happening in 2005, which looks like 27.8-ish. So this would be called interpolation, where you're predicting within the domain of your graph, meaning we're between 1990 and 2008. So by looking at 2005 there and making this prediction of 27.8, that would be interpolation because we're estimating within our group. Extrapolation is where we make a prediction beyond our data. So that would be if I use this line, because we could keep graphing it, I could expand my axes here, but like I could estimate what would happen in 2010 if I continued that line. So maybe that would be 30. 30% of people were college graduates. However, we want to be careful extrapolating too far away from the domain, because this line works great for our data and within our data, but going beyond that, since we don't have the information out there, we don't know if it continues to be linear. Like who knows what could change who knows what could change in the world? We know it can change in the world in 2020, and maybe that affects the percentage of college graduates. Either maybe there's a great increase because it's all online due to the pandemic, or maybe there's a great decrease because people needed to work. We could see these events occur that would change the data and change the trend of the data, and with that, we don't want to go too far beyond our data and what we've observed in making predictions.